given that we have some roots of a polynomial function, and we want to figure out what the polynomial function looks like, least degree having only real coefficients. And here's the answer right here. Question is, how do you get to that? Notice over here that I've turned complex mode on Desmos by clicking the wrench icon up here and sliding this over so that I can type numbers like 3 minus I. So you can see f of 3 minus I is 0, f of 3 plus I is 0, f of 2 plus the square root of 6 is 0, f of 2 minus the square root of 6, well, that's really close to 0. Desmos just couldn't figure out exactly. But those are the real roots right there. We're going to use this theorem right here, that if we have a complex 0 where b does not equal 0, then its conjugate is also a root. And so we're given that 3 minus I is a root, so that means 3 plus I is a root. And we're also given these two roots. If those are roots, then x minus each root has to be a factor of the final polynomial function. So I can rewrite it this way: x minus one of the roots times x minus one of the other roots, etc. And the easiest way to multiply these together is to distribute the minus sign and do some regrouping. So like if I distribute this minus sign right here, I get x minus 2 plus the square root of 6, and then group the x minus 2, the x minus 2, the same for the complex zeros. Why do I do that? Because a minus b times a plus b results in a difference of squares, a squared minus b squared. So here I'm multiplying the sum and difference of the same two terms. I get a difference of squares. So I can say the result of multiplying these two factors right here is the first term squared, x minus 2, minus the second term squared, which would be a minus 6. And if I can square that binomial, I get that minus 6, which ends up being x squared minus 4x minus 2. And the same over here, except I squared is minus 1, so this becomes 9 plus 1, or 10. And here, I kind of showed the work to multiply these two trinomials together using vertical multiplication. So I'm taking x squared times each term in the numerator up above, then negative 6 times each term up above, and then 10. I write them on separate rows so that similar terms are above each other. There's your final answer. Okay, the roots of that polynomial function are 2 plus the square root of 6, 2 minus the square root of 6, 3 minus I, 3 plus I. There you go. Hope that helped. If you have any questions, post a comment. Oh, by the way, some textbooks give you a formula for multiplying these factors together. It's something like x squared. If we're multiplying a plus bi, x minus a plus bi, and times x minus a minus bi. You can look it up. There's a formula. It's x squared minus 2ax plus a squared plus a squared plus b squared, something like that. I might have got that wrong, but I just like to do it this way. I can't ever remember the formula. There you go. Hope that helped. If you have any questions, post a comment.